Okay, today's class, we are going to go on with the theory and prepare the next lab session that will be on Wednesday. And I wanted also to comment on the last partial exercise, for which I sent several activities. And I don't know, because we haven't had too much participation. So let me so I don't know if we can see this larger. Okay, I would like to hear about some of the questions in the exam that were very, very basic, and I don't know if there was a problem of understanding or whatever. So there have been, I think, two answers to this question, but I don't know if it's clear for everybody which are the correct answers for this particular exercise as one example in the exam. So okay. Could you tell me what these three quantities are? This capital P of, we have three classes, W1, W2, W3. Could you tell me, please, what these quantities are? Priors. And this? Small p, a number given a class. What these quantities are, or well, what you have to put there are quantities. But each of these is in fact what? Class conditional is the name. It's a probability distribution. And this capital P is the posterior, the most important amount. Uniformly distributed between -1 and 1. -1 plus 1. Uniformly distributed. And I'm asking about x equal to 0, x equal to 0, x equal to 0, 0, 0, 0, 0. So we have to concentrate at x equal to 0. But anyway, we have to understand the problem first. The most important thing here, apart from understanding the problem, it's up to you, understanding it or not. And anyway, the most important thing here for this particular problem is that all class conditionals are the same. Is that clear? So this is class 1, the same is class 2, the same is class 3. So there is only one answer here. What's this value? Well, it depends, because this has to integrate to 1, so the wider the support, the lower the value. If the support was 1, the height would be 1. 1 by 1 is 1. If the support is 2, as it is, the value is 1/2. Okay? That's not important, but is what it is. Okay? So the correct answer here is 1/2. But that's not important. Not as important as other details. If the conditions are the same for the 3 classes, then what does the optimal classifier for this problem? Well, the optimal classifier always does the same. Computes the posterior and takes the maximum. That's the Bayes classifier. That's the most important thing. Understand what the Bayes classifier is. If you have all the information, you can always compute the posterior and take the maximum. That's the Bayes classifier. Because in this case, the conditions are the same, then, because what would be the unconditional in this case? Do you remember the unconditional? This is the class conditional probability for each one of the classes. What is this? This is nothing but an average, a weighted average of the conditionals. But as the conditionals are the same, any weighted average of the same thing is the same thing. So this is also the unconditional. So if you remember the formula, the posterior is equal to prior class conditional divided by the unconditional. But this is the same. So at the end, the posterior is the prior. So whatever you put here, you have to put it there. So in this particular case, conditionals are the same for all classes. The detail what decides it's only the prior. So which is the Bayes classifier? Can anybody tell me which is the Bayes classifier, the Bayes rule? How we decide, given any input between -1 and +1, how are we deciding each of the three classes? Which one is the Bayes classifier? Because without this, you cannot go on. What's the Bayes classifier? What's the posterior for each class? Well, this is proportional to 1, 2, and 3. So it's 1/6, 2/6, 3/6. So this prior is 3 times as big as this, and 2 times as big as this. And all of them sum to 1. But that's not important. What is more important is that this is the highest prior. The same here. So which is the Bayes classifier?
The one with the one with the biggest prior.
Yes, and this is class 3. So the Bayes classifier decides always 3. It's a constant classifier. So the output of the classifier is independent on the input. No matter you put at the input, it answers 3, always. Is that clear? Was it clear? Anyone? First of all, we were asking here for the confusion matrix. First of all, what's the size of the confusion matrix? 3 by 3. I'm afraid that in the whole exam, nobody answered a matrix of 3 by 3 size. 3 by 3? Can anyone tell me which is the well, first of all, we know about 2 types of confusion matrices. Confusion matrices with counts. For example, in the case of 2 classes, we give names to the entries of the confusion matrix. We talk about true positives, true negatives. This is only for 2 class cases. True positives, true negatives. But these true positives or negatives can be rates or counts. And the rates can be interpreted as frequencies. If we have points, then we have proportions. But in the limit, This is probabilities. If you have a look at the slide, when we define the coefficient matrix, we talk first about probabilities. We don't have points here. We don't have data. We only have description of the problem. So the only matrix we can refer to in this case has to be the what we call normalized coefficient matrix, in which what we put here has to be rates or probabilities. Okay, can anyone tell me which is the correct confusion matrix?
If the classifier always is going to say that the class you are analyzing is 3, it should be 0, 0, 1, 0, 0, 1, 0, 1. No?
Any other answer? Do you all agree?
Well, it makes sense. But why we say always this?
Because the posteriors for each class, posterior for class 1 is 1/6, posterior for class 2 is 1/3, and posterior for class 3 is 1/2, which is the highest, 3, always. So the classifier always says 3.
But that's only in the case that everything is between the interval -1 plus 1.
We are starting saying that input values are uniformly distributed in interval means 1, 1. There are no other points outside that. If they were, the distribution won't be this one, would be different. It's important to understand the concepts apart from the formula. I mean, formulas can be, sometimes beautiful, sometimes disgusting, but apart from that, the concepts itself are not so complicated. Okay? What would be the probability of error at x equal to 0, and what would be the Bayes error rate? This answer you have answered correctly to that. Someone wrote in there that, in fact, in the slides, we were writing these expressions for 2 classes. And I suppose that this is quite clear for 2 classes, but now we have 3 classes. What's the probability of error, either at x0 or in the whole space? The only difference is taking this value here or integrating through the whole support. But in this case, everything is constant. So the answer for x equal to 0 or for the whole space, the error rate or the probability of error at x0, the only difference can be a constant. But I mean, the meaning is the same. What's the important thing? The important thing is that when we have two classes, the Bayes classifier decides one of these two, and the error is the probability of the input is from the other class. That's why the Bayes classifier always takes the maximum of the posteriors, and the error is the minimum, the other one, because maximum and minimum, when we have two, the minimum is the complementary of the maximum. But now we have three. Bayes decides the maximum. What is the probability of the error? That the input comes from either class 1 or class 2 with corresponding probability. Okay? You don't need any formula to answer this. I mean, if half of the time inputs come from class 3 because of this prior, and Bayes classifier always is correct for this half. What's the probability of error? The complementary, the other half. In fact, the complementary is the sum of the prior probabilities of 1 and 2. Of course, 1/2. If you go through the formulas, you have to generalize them for 3 classes. But you don't need to do all this to answer that. And this rate, it's 1/2. Has to be. And what would be the value of the probability of error at x equal to 0? This is not a good writing of the question. But I mean, you must understand this as the distribution of the errors in the space. You need to know that the integral of this over all the values of x, not only x0, the integral from -1 to +1 has to be 1/2. And the support is 2. So what's the answer for that? If it was 1/2, when you integrate over the whole space, it will be 1. This is not easy if you go through all the formulas. It can be difficult. Well, in all these questions, there are easy parts and difficult parts, and important parts. The most important part is hidden because it's understanding what the Bayes classifier is. That's the most important part. And most of the aspects were easy. You don't need any formulas to arrive to that. But you have to think a little bit more to answer this. You should make sure that you understand this. Okay? I was planning to do an exercise here, but I haven't had time. I will upload some exercise if you want to go a bit further with this and finish understanding these concepts. Any questions about Bayes classifier about basic parameters, about confusion matrices. Any question? We will be having another partial examination. I don't know exactly when, but in this new partial examination, you will have also question on that. So you should not forget this. Okay? The same kind of problem, instead of uniform distributions, Gaussian distributions. Instead of one dimension, two dimensions. We are talking about the Bayes classifier again. And we are now asking about the boundaries. Almost everybody has answered this partially correct, but I would like to go a little bit into the details. Almost all of you have agreed that this is the mean of class 1, this is the mean of class 2, this is a Gaussian distributed like this, and this is a Gaussian distributed like this. But anyway, the points lying in this line that goes, of course, to infinity are points that are at the same distance, Mahalanobis distance, from class 1 and class 2. I think almost everybody has answered this correctly, but some people have stopped here. I don't know why. I don't know why. Because you know that the boundaries have to be, well, are the region of the space where the probabilities, the posterior probabilities, are the same for the two classes. So if I go like this, at this point, the posteriors are the same. So certainly the boundary goes from from infinite to infinite. Do you all agree? Okay. Imagine that these Gaussians, instead of being this like this, imagine that these Gaussians were like this, with unit covariance. In this case, this would be the exact solution. Because in this case, if the Gaussians were of unit covariance, then this classifier is absolutely equivalent to the minimum distance classifier. In fact, now the same classifier can be formulated in terms of distance, Euclidean distance. And the Euclidean distance from any of these points to the two classes is equal along to this line. And that's all. Okay? But Let me ask you some questions. I will leave it open. Take a point into the x-axis and move in this direction, very, very far away from this line, or not so far away. What would be the class assigned by the Bayes classifier to this point? Because, I mean, the boundary separates class 1 from class 2, isn't it? If the boundary was that, then this point should be classified as class 1. So the question is, this point, the classification of the Bayes classifier for this point is 1. Are you sure? Just think of the following. The meaning of this is that when you compute distances along this direction, the same distance, this distance, and this distance is the same. So we can count. For example, imagine that this is unit distance, more or less. 1, 2, 3, 4, 5, 6, 7. So this is a distance 7 from this. What's the distance from this point to this class? This. Well, from this class, as the coordinate is of this shape, we have 1, 2, 3, 4, 5, 6, 7, 8. You see it? I don't know, more or less. 15. To say something. What about this point? Well, now we don't have this direction in which this is the unit distance, or this direction in which this is the unit distance, but we have this direction which is slightly higher, you see? So what's the distance from this class to this point? More or less. 1, 2, 3, 4, 5, 6, 7, 8. You see? So now, what's the class that will be assigned to this point by the Bayes classifier? 2. So something must be wrong. The boundary cannot be just this. You understand? This question was not meant for you to get the correct answer, because if you don't see this particular case, well, maybe you don't. So, for the case of the exam, this is good. Good answer for the exam. But it's not the correct answer. The correct answer is that somewhere around here, more or less, we have let's delete this. somewhere around here, we have something perhaps like this, in such a way that these points must belong to class 1. Something must be happening here. It's okay? The region around here has to belong to class 1. So something like this must happen. But is this possible? Is this shape possible? Because you know that we've seen that when you have Gaussians, the boundary is always hyperquadric. In 2 dimensions, this means a hyperbola or a parabola. Has to be. Is this a particular case of a parabola or a hyperbola? No. No. Can't be that. It can be that. It could be this. In fact, when this is circular, this is the solution. But a line is a particular case. No problem. No problem. But now, what's the solution? Let me tell you. Well, first off, maybe you will guess it. What will happen? Now imagine that I take this class, and instead of having the same covariance rotated, instead of that, imagine that this would be smaller. What would happen? Wait a minute. Smaller means that the distance, the same distance is longer. So these points that are the same distance, now this point is closer to this than to this. So what would happen? Someone started to talk. The line? So it still will be a line. Well, you not necessarily are supposed to know it, but I mean, if you change this, because this is a line, because these two distributions are exactly the same. If you change one of these in shape, then this line is no more a line. It would be a quadratic line like this. If you've seen several examples of Gaussians, you have several examples of Gaussians in the slides. When we have different Gaussians, then the lines get curved, going closer to the Gaussians. That the problem is, well, the difference is when the Gaussians are exactly the same, when they are the same, we know that they are lines. In this case, it's a very particular case in which the Gaussians are like in the opposite directions, but they are exactly the same. If they are not, then this is a quadratic line. But, I mean, this has to be like this. But how it goes now? This should be quite clear from the example we have in the slides. If this is like this, This goes to infinity. Then arrives here, and now what happens? What happens? Has to be. But the thing is that this is the solution. This is the solution to an equation of degree 2. This solution doesn't comes alone. This solution comes along with. This is a complete solution. Always. I mean, even in the examples you have in the slide, the thing is that when we have two Gaussians, we only show the important part. Which is the important part? Well, the important part is when we have the overlapping. Here, the problem. This boundary is the important boundary. But this is also boundary. I mean, mathematically, we obtain this. This is the complete parabola or hyperbola. Has to be like this. If this grows a little bit, then this shape gets closer to the line. Gets closer to the line. The closer this goes to this, the closer the arms of the parabola get to the linear, the lines before. Now, which is the exact Bayes boundary for this problem? Something like, more or less, this, which is the limiting case of a parabola that becomes not a line, two lines. The region here belongs to class 2. And the region here belongs to class. But the thing is, we have no points in this area. Almost all the points are here. So all probabilities here are almost 0. But the boundary is like this. I mean, it's almost impossible that you will get this correctly. That's why, for the exam, this was considered a correct answer. But my plan was to later show that. The second case is basically the same. I just want to comment on the third one. This, we rotate this, and then we have this second Gaussian just on top of the first one. You understand what is this? Is that clear? We have two classes, and the class conditionals are the same. What happened now with the priors? Nothing is said about the priors. We are assuming all the time that priors are the same. If conditionals are the same and the priors are the same, what is now the Bayes classifier? There are two possible answers. What is now, if one of the priors was higher, then the Bayes classifier answer this class. It will be a constant classifier. But now the priors are the same. Everything is the same. So what's now the Bayes classifier? If you go to the slides, The slide says undefined. There is another answer. I can't remember if we commented on that, but if you go through the documentation, the problem is what is our decision on the boundaries? Our decision on the boundaries can be no decision, defined, or random. So we could accept as an answer just decide randomly, because prior are the same. But the question was not which is the Bayes classifier. The question was, what is the boundary of the Bayes classifier? And this has only one possible answer. Which is the boundary?
The shape of the point.
Something like this? Any other answer?
A plane vertically.
A plane vertically? What is a plane vertically?
They are one and two are
The same. The same. It's a Gaussian. There are two Gaussian, exactly the same Gaussian. The input space is this two-dimensional space. The distributions are distributions like this, Gaussian like this. But in this case, the two Gaussians are exactly the same Gaussian, and the priors as well. So the posterior probabilities are exactly the same for both classes over all the space. So again, which is the boundary of the Bayes classifier? The boundary is the region of the space where the maximum, the decision of the classifier, changes.
There is no boundary there.
No boundary. I think there is a boundary. I can understand your answer, but I mean,
Is the entire space?
the entire space. Everything is boundary. Clear? Now imagine that the prior is the same. Now imagine that the prior one is 1/3, 1/3, 2, 2/3. Imagine the same problem, different priors. Then the Bayes classifier was the one from the other exercise. Okay? Okay? What would be the boundary?
Every sample will be classified
As class 2. So
it is nothing. The boundary is always class 2.
So the answer is, there's no boundary. let's have a break, 5 minutes break, and then we will go on with linear perceptrons. Okay? I will upload after the class perhaps an exercise or two related to these questions, so that you can perhaps practice or do whatever you want. Okay?